Now I change my hat again, and I change also the microphone. So the next presentation is with two persons, so it's a double presentation from Madame Oufa and Madame Brahim from Serist in Algeria. They will speak about Abinit application. Madame Oufa.
My presentation will talk about Abinit as a first step on grid infrastructure and the Reds project. My presentation contains two parts. The first part that I will present to you, and the second part will be presented by Mr. Lagoun. So the first part, it's talk about the Abinit as code that has been deployed on the grid infrastructure using the Science Gateway. This achievement has been done under Reds project. So we have implemented our Science Gateway, Algerian Science Gateway. Our portal gives another way to use applications to the large communities of scientific researchers in some science domain. In the case of Abinit, is under the materials science domain. So the Science Gateway offers an interface that provides tools to users to submit their application, to use the Science Gateway to submit their application to the grid infrastructure and hide the complexity of the middleware and of the grid. So, it change the way of the infrastructure they are used. Before using the Science Gateway, users, in order to use the grid infrastructure, they use command line. So this allows many users very far to use the grid because they have to cope with complex security procedure, execution script, job description language, and command line. So all this thing makes the learning curve very steep and keeps no expert away. That's why we are using now this portal. So our Science Gateway portal based on life-ray technologies with the Catania Science Gateway framework using the grid engine. The authorization is based on the identity provider. It belongs to the GREDP Federation. The authentication is based on LDAP. We have deployed many applications that has been developed by ENF and Catania team. These applications are Octave, Gromax, Air, and Abinit. So here you can see the portlet that has been developed and deployed onto our Science Gateway. So the customization of the portlet, it's we have integrated the both mode, sequential and parallel. And the execution works well with demo and real analysis. So you can see here the portlet developed. So that allow to the user can use the both modes, sequential and parallel, can use the number of cores that is used in his code, and after you can include inputs files. And finally, he can submit his application to the infrastructure. In the Science Gateway, we have added also the tools that allow to users to monitor their job, their application. So he can find the list of all applications submitted to the infrastructure, and he can get his output after the execution. So this briefly my presentation that has been done. So now I will allow Mr. Lagoun to present the use case of Abinit on our infrastructure.
I'm Lagoun Brahim from Lagoun University in Algeria. I will to thank CIRIST and ENFN to the collaboration to develop the portlet. Well, the Abinit application is it's in code for material science. Material science is very important area of research because we have always needed of new materials with high performance properties. There is three different disciplines in the material science: the experimental, the theory, and the simulation. The simulation at the atomic scale, there is three different methods. One of the important methods is the density functional theory. The historical of this theory is summarized in the next. The Thomas Fermi model in 20s, the paper of Homberg Cohen on and the paper of Cohen-Sham in 16s. The use of LDR, local density approximation, in 70s and 80s. The dynamic molecular with DFT, the Calparino methods in 85. Other functional of exchange and correlation used by chemistry in 88. The modern theory of polarization in 94. The density functional perturbation theory in 19. The recent study of the static in journals of physical review demand between the 10 most cited publication, there is 6 with the term of DFT. And the number of publication per year increased exponentially in recent years. What we can calculate with the DFT calculation, there are many properties very important we can calculate with DFT. The structural properties, we can plot the energy curve with the volume or the cell parameter. We find the cell, optimized cell parameter, and we can find the pressure of the change of the phase. We can calculate the electronic structure of materials. We can calculate the electronic density and the band structure and density of state. With this, we can find the nature and the energy of bonding in materials. We can calculate the optical properties with the imaginary part of the dielectric function. We calculate this We calculate the electronic transition. With this, we can calculate the other properties, optical properties, the dispersion of refracted index, reflectivity, energy loss, and so on. And we can calculate other properties like elastic constant, piezoelectric coefficient, and thermodynamics properties. There is many code based on DFT theory. Why we choose Abinit? Because it has disadvantage. It's an open source code. It's easy to install, easy to learn. There is an implementation of DFT and the dynamic molecular, implementation of TD-DFT and GW and the DFPT, and the parallelization with Abinit is over bends and cap point and spin. Then the calculation it's very quickly. In our case, we have studied the two properties of family of materials, the elastic and piezoelectric properties. For do this, we have to following this map. Firstly, we have to do a convergence study to determine the parameter of calculation. Then we can do an optimization and relaxation of the structure, and then we can apply perturbation to calculate these properties, because properties of materials is the response of these materials to external perturbation. This last etap is the very hard one. For this, we need the grid. The result we obtain with the calculation using the grid is 9 elastic independent elastic constant, 5 non-zero piezoelectric coefficient, and 3 direction in these materials with 3 dielectric function. We can show a video. Then for submit a job, we seek in the we identify the user. Then we choose an application. In this case, it's Abinit. In this portlet, we have a short description of Abinit and a short tutorial to use the portlet. We have to choose execution in parallel or in sequential. If we choose a parallel, we have to choose the number of the curve. Then we can upload a file, who is .in files. It's a file, text file, contain the parameter of calculation. We upload the pseudo potential, one for one element, and the dot files file. Its file contains the name of input and output files. Then we enter the name of files who needed, and if we want the description of a job, then submit the job. we can view the job study. After the end of the job, we can download the output. After downloading the output files, we can merge the data in this output and utilize other application to analyze the result. In this case, our results are the piezoelectric coefficient and the elastic constant.